In today's class, we are going to see the topic called scalar and vectors in biomechanics. So the learning objective of today's class is that we will be having a brief introduction of the basic concept of biomechanics, mainly focusing on scalar and the vectors. Because the whatever physiological, physical quantities we are measuring, it falls under the category of either scalar and vectors, and how the physical quantities are differs and how it's going to be help in to understand the biomechanics. So again, I'm starting with a, empathy perspective of why this particular topic is very important when you want to study biomechanics, because with help of biomechanics we can do all sort of movement analysis, right? So these movement analysis which involve the physical quantities, either scalar or vector quantities. If we don't have a proper understanding of these basic concept of vector quantities or scalar quantities, there is no proper or accurate movement analysis can be made. There may be some misconception, misassumption or misunderstanding of these quantities will happen, that can cause any sort of injury or improper designing of medical device or improper treatment plan. So that is the thing here. We need to understand the basic concept before we getting into big things to do a miracle in biomechanics or to design the device later to biomechanics. So that is the thing I have bring this particular topic here to discuss why the scalar and vectors quantities matter, what is actually how it is differ. Okay, so let me start with the basic definition of what is scalars and what is vector. So if you see all physical quantities, either it can falls under scalar quantities or vector quantities. The scalar is something the quantities which have the magnitude. Okay, it means that it describe how much of something. So if you want to quantify something, then with only magnitude, then it is called scalars. If you are saying along with the direction, that is magnitude and direction, then it is called vectors. So the example for vectors is your displacement, velocity, force, and acceleration, because these are the things having both magnitude and direction. Whereas in scalars, it just say how much of it. Okay, it doesn't have any direction, whether it has positive direction or negative direction. It will not give any lead of that particular magnitude, so it is called scalar. So the both things are very much essential when you want to do the biomechanical analysis, because the biomechanical analysis is full and full either scalar or vector quantities. So the scalar quantities in biomechanics examples and application is that you have example like mass. For mass here we can say body mass, your tissue mass, that is tissue density, speed. You can have a linear velocity magnitude speed, that the way you are walking, and temperature, your body temperature, and energy, the energy which we hold inside, that is the kinetic energy and potential energy. The application with help of this scalar biomechanic is that you can do the performance analysis of your body, that is your movement and body movement. And second one is you can even assess the injury. Okay, in what condition the injury has occurred, how extreme it was, in what stage it has been occurred. Everything we can do assessment with help of scalars. And also you can do the thermal imaging, because there is the involvement of temperature. You can have a heat distribution, that is the temperature distribution of the skin of your tissue. So with the help of that you can identify so many problems. One such device is called thermal imaging technique. Second one is vectors in biomechanics. So vectors, as I said, this is the quantities which have both magnitude and directions. So example for this vectors in biomechanics is your force, velocity, acceleration, and displacement. Here the force is nothing but your muscle force, the joint action force, and your external force. These all type of force actually interact in your body to have a one movement. So that when you are dealing with that type of force, then it is called vectors in your body. And velocity also, you have a directional movement analysis, and acceleration is the rate of change of velocity, you know already, and displacement is the change in position with the direction. So if you see any type of these vectors example, there is an involvement of magnitude and also the direction. So application of this vector is that you can do the movement analysis as like scalar, and you can study the injury mechanism, and you can have a rehabilitation recovery program planning. So this is the example for vectors. So vectors operation is biomechanics is not easy like a scalar because it is the involvement of what direction. So vector, I mean scalar, you can easily do addition, subtractions because it is having only the constant value. But it is here the thing of vectors, that is the involvement of since there is the involvement of direction along with magnitude, it is not that easy to add, I mean do operation with vectors as like scalar. You have so many things to taken into consideration when you are performing operation in vector. One such is vector addition, second one is vector resolution, and third one is dot product, and fourth one is cross product. Because there is no single force or single motions being involved in every moment. There is so many muscle force or so many a bone force, everything is there. Even external force also a counter into part. So when you are having a combination of these multiple force, then you need operation. Okay, you need to do addition, subtraction, or you have to split and so many things. So for that only we have these four things. For vector addition, you can combine the multiple force. Vector resolution, you can break down the complex force into the components. There are the things you have to break it out and the solve it, because as a whole it is not easy to compute the values. So in that case you have to break down the complex force into the small one to carry out the task process. And third one is dot product. Here you can calculate how much of work is being done by the force, and by means of cross product you can determine the moments and torques. So these are the vector operations in the biomechanics, where it can be used especially in the application like joint mechanics, balance analysis, and movement analysis. So in today class, we had as a summary, we had a very general basic introduction of what is scalar and vector quantities, how it is differ, and what are the example followed by the application in our body.